Okay, good day. Let's try to put the load patterns and load cases, including the internal wind pressure on ETABS and onto our model. So, see the video about the modeling of the gable frame or the hanger on part 1. This is part 2, and we shall try, to see if we can input. So, there is also a part 3, and part 3 is where we can try to do load combinations for LRFD and ASD. So LRFD and ASD has different load combinations and has different videos because we will try those shear and moment diagrams for our design of steel, no? So later I will do a video about that. So first, let's try this one. So as you can see, this is our perspective, and this is our hanger. So these are the elevations. We have done this one in the modeling in ETABS. We have done this in part 1. So first, let's consider this. So our wind speed is 300 kph, assuming that we have a 300 kph wind speed. As you can see, mostly in the Philippines and mostly in our part of the country, it is mostly 300 kph wind speed, as we have seen in the internet, no? If in the based on NSCP, yes, no. So let's try global wind load. So this is what I'm talking about, wind zones in the Philippines. So this is I'm talking about. Let's see if there is if this is 300 kph. So I have tried, no. So anyway, so let's try. Let's double check. So this one, Kabakan, North Cotabato. So as you can see here, this is 300. This part is 300. So Kabakan, no. Okay, if you are in Osias, it is 300. So we assume it is 300. I can also assume 290, but I just want to assume 300. So 300 is so just 300. So I don't know what's this. Back to home page. Okay. So anyway, let's go back there. It's 300. You see. So um slideshow. Okay. So you can see an exposure type. We assume letter B. Ground elevation factor 1 and topographical factor. See the example on topographic factor. We assume that it's 300, and the topography is in what, in the area of Arakan. No? Let's assume that it's 300 kph. Anyway, this is for just academic purposes. So I want you to solve topographic factor if the topography is escarpment, or what we call that, ridge. So for gas factor, first we need to see the, what you call that, modal analyze. So let's set load cases to run. So run. So we just need to see the modal frequency, the mode 1, or the fundamental frequency, before we go. Okay, analysis result, structure output. I have shown you this one in part 1, but let's try. So it's 0.993, and as you can see here, if I input 0.993 and 300 kph, and based on B, on exposure B, we have a gas effect factor of 0.99, or almost 1. So if it's a rigid structure, G is equal to 0.85. And obviously, this is less than 1 hertz. So this will become flexible. So it's 0.993, no, is less than 1 hertz. But I can also assume this as a rigid structure, guys. But as you can see here, as I have discussed in gas effect factor, it is this V that determines our gas effect factor. But since we have a strong wind here, let's consider one. No, let's consider one. If, for example, our wind is just only 150 kph, then we can assume G is equals to 0.85, but it is 300. So there is a play, there is what we call so anyway, 30, 36, 14. This is let's try if we change it, so it's still 1. So just we assume 1, no? Still assume 1 if it's parallel to the ridge, then if it's normal to the ridge, it's 30. So anyway, it's still 1. We assume it's 1. So we try to consider this larger value than this 0.85 because there is this parameter here, wind. No? Wind plays a role, and gas is also a wind. No, it's just not a sustained wind speed, but gas is also a wind. So instead of considering G is equals to 0.85 because 0.993 is almost also 1 hertz, then let's try 1. So also your judgment, no? It's still your judgment, guys, but as you can see, gas effect factor, let's try it as 1. So let's continue. This is our wind coefficients now. So as in my judgments, I'll consider gas factor as 1 and not 0.85. Although 0.993 hertz is almost 1, I'll just consider this one. So anyway, this is just a minimum wind load, and I want to be above the minimum wind load if it's 0.85 gas factor. So as you can see, we have different load patterns here. This is the load pattern. So you already know how we computed this one. So this is for the wind direction normal to the ridge, and based on the enclosure classification, this is enclosed in the wind direction normal to the ridge, whether the door is closed or the door fails. No, there is no close for the door. No. Then we have the parallel. So this is, I assume that this load cases or this scenario for the parallel to the ridge, that there is no door failure and the doors are closed. Therefore, the enclosure classification of this is enclosed, and that is why plus and minus 0.18. So the coefficients here are we have discussed, no? We have discussed how we done this. So anyway, let's go. So in our internal pressure, as assuming doors are closed during strong wind, no door failures or no door failure. So our GCPI is plus and minus 0.18. If CPI is 0.18, then G is equals to 1. So maybe you are confused here, guys, no? The G here is not separated to GCPI. It's a whole, but since it's only CP that we need to input in ETABS, no? It's only CP. Then if we consider CP as 0.18, then G is obviously 1. So this G is not the same as the gas factor in the previous slide, no? In the table earlier. This is the G in GCPI. And we just need to separate G here because we need to separate G here since what you call that, the only thing that ETABS needs in inputting is just the CP. So I hope you understand, no? So except for gas factor, this is a gas factor. This gas factor is different from the gas factor earlier. So anyway, let's proceed. So it's just a coincidence that our gas factor in the previous slide is the same with G here. Okay, it's also a gas factor for CPI. So anyway, so other loads we try to I'll just try to input, no. So I don't neglect roof covering, the roofing, the metal roofing. I assume it is 0.14 kPa, and I found it's on some especially in NSCP 2015 you can see 0.14 kPa. Steel purlins I just assume 0.3 kPa. I really don't have any idea how much is this loading here. Just assume 0.3 kPa, almost two times of the deck metal gauge. Anyway, this is just for academic purposes. It's still your judgment on how you will input dead load, no? It's for you. It's for your own judgment. So load pattern live, you can see this one in ASCE. So maintenance, re-roofing, and during construction, it's 0.96 kPa. There is 1.33 kilonewton, but it's what do you call that? It's loading, concentrated load. So I just assume 0.96. So anyway, this is really not part of our wind loading, no? But for the sake of ETABS, because or for the sake of load combinations, I have put some here. So let's go to ano. So I spent almost 10 minutes here discussing this. So let's go here. So what shall we do here? So let's unlock it. The purpose of this one is to find the fundamental frequency. So let's try to input some loads here. So first, let's define load patterns. So how many load patterns should be defined? So we have 3 load patterns. So why 3? We have the WN, load pattern. So load pattern, sorry, 5 all in all load pattern, that is WN, load pattern 1 WN for the case of negative 0.48, wind normal to the ridge 2 in the case of negative 0.034 for the, what you call that, the windward roof, no? Then load pattern 3, wind parallel or WP underscore 1 for 0.90 and negative 0.18 for load pattern 4. So we have 4 load patterns for for both scenarios, scenario A and scenario B. And under these scenarios, for load pattern 1, we have two cases. So case 1 is we have this positive 0.18 and negative 0.18, and also for load pattern 2, two cases. Load pattern 3, two cases. Load pattern 4, two cases. And we have 8 overall cases. So our next load pattern is WI. So we have 5 load patterns. So let's do this one in ETABS. WN underscore 1, that is our first load pattern for wind. Yes, he is 7-16. Add new load. Then modify lateral load. So our, let's see here, 186.41. So I'll just move it here in my ano. So 186.41. This is 300 kph. Exposure type B. Ground elevation factor is 1. Topographical factor is 1.69. Gas factor, instead of inputting 0.85, I'll try 1 because that is how that is the computation of my gas factor. Although I can consider 0.85 because 0.993 is almost 1. But I have explained it earlier that it is my judgment to use 1 because of this 300 kph. So anyway, directionality factor is 0.85. Okay. Then let's click this exposure from frame and shell objects and only shell objects. So our story exposure height is all. So this will try to solve windward wall based on this height, because windward wall is different than leeward wall and the roofs. So roofs uses the H, the mean roof height, while windward wall uses Z. So anyway, that is the auto loading. So since we have established already this one, let's try to just, okay, why is it that there is no copy loading here? So add new load. Oh, this is so, I don't know why there's no copy load here. It's this is bad for ETABS, no? I just noticed there's no copy loading. So anyway, let's try to do this one by one because there is no load pattern to copy. No, there's no copy. Oh, they forgot to put copy. So anyway, let's just manage to do this one by one. So add new load. So 2. So let's try modify lateral load. For sure. Why is it there's no copy? Okay. Anyway, I'll just do it all. I thought, okay, 1.69. Okay, let's try. Then WP2, add new load, modify lateral load. So just do it the same, no? All the ETABS, especially I think ETABS 2016 has a copy. You can copy different load patterns, but I don't know why this one has no load copy. So, okay, okay. Okay, so let's check. Okay. Let's check. Okay. 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 Then lastly, our wind internal WI. So add new load. Same, it is 186.41 also. Topographical factor 1.69 and gas factor 1. Then exposure includes shells. So 0.85. Okay. So we have this already load patterns. Now we need to input it one by one. And later we will try to do this in case 1 or case 2. So anyway, um, let's try. Okay, WI, WP2. So G here, it's just a coincidence that the G in GCPI here is the same with the gas factor we have computed using this one. So don't be confused about the internal pressure. So this is how we try to include the internal pressure in ETABS. So okay. Now next, what does it mean? No, as you can see here, I'll go back here. As you can see here, negative 0.48 means outside. Negative 0.48 means negative pressure or suction. And as you can see here, there is this direction, no? As you can see, the direction is going outside, no? Going outside. So, if we see a negative pressure, meaning this is uh, towards outside, no? Towards outside, no? So, as you can see here in our ETABS, we have tried that all of our shells are uniform in their local z direction that is outside. So therefore, we will use positive for all suction and negative for all positive pressure. So I think I know that you have understand it well. So guys, don't forget that. So first, let's consider the wind load pattern 1. Load pattern 1, WN 1. So I'll try to do this. So just forward the video if it takes too long. So first, this is our okay, point 7. Okay, sorry. So assign. So assigning loads, just click assign shell loads, then wind pressure coefficient. So WN1 on first, our first is WN1. That is what do you call this? Negative uh, negative zero point 0.7. So since this is a wall and this is side wall, click leewards or sides. Okay, apply. So also we can also apply it in WN2. Apply. Okay, sorry. Apply. It's okay. We have applied it. Okay. So I can select. So also apply. Okay. So I have applied it, no? Where can I see the application of ano? So anyway, yeah, as you can see, I have applied it earlier. So let's try to see. Then let's try application for the back side. This is side wall for uh, so it's hard to click. Okay, two shells to edges. So be careful guys, no, in inputting ano shell loads. So that is one apply. Also for WN apply. Previous also apply. So next, after that we have applied. Let's try this one. So if this is our ano, if this is our front and wind is blowing here, although it's still the same, it does not change. Then our loading here is point 0.8. So it's positive. So since this is positive, we need to okay, I'm very sorry guys. This should be This should be positive, no? This should be positive and assign. I will try, no? CP. So click CP. This should be positive. Apply positive. Then select previous. This is select previous. Uh, Again, let's try to apply. Okay. Then next here, let's try to apply this one. Assign. Shell loads in pressure coefficient. So apply. Then WN2. Again, apply. Okay. So let's try. Mm, for the windward side, this is going outside. No, this is the local z-axis here is going outside. Then let's try. Let's try to what you call that? Flip the sign here. So assign shell loads wind pressure coefficient. Then that is negative zero point 0.8, and this is windward. So we apply. Then for WN1, we also apply. Okay, sorry. Don't forget to select previous, then apply. So anyway, next for our side here, finally, this is what we call negative zero point 0.5, no? So assign shell loads, wind pressure. This is zero point 0.5 positive suction leeward. So apply. Then PS. Also for the wind normal to apply PS. Let's check again, apply PS. So finally, our roof. So our roof, okay, assign. So this is the windward roof for WN1. It's different for WN2. So let's try first our leeward roof, because leeward roof for both load pattern WN1 and WN2 is the same. That is negative 0.568. So as you can see here, it is it's the same, no? So it's the same 0.568, 0.568. So we consider first you call that we consider first this side, this wall. Consider first this wall. Sorry, this roof. So next, assign shell loads, so wind pressure coefficient, then still leeward. So we use the leeward, guys. Why? We use the leeward because leeward uses the mean roof height QH, no? QH. So leeward uses the mean roof height QH. Also, since all roofs uses QH, we also use leeward for the roofs. So this is why we should use roof. So leeward only uses for the wall, that is windward wall. So don't forget that, guys, ha. So for this roof that is negative 0.568 going outside, so positive 0.568. So apply. Let's apply because it's negative, oh. Since this is negative going outside, we try to input positive. So positive. Apply. So, okay. For WN1 also, that is the same. 0.56. Apply. Okay, sorry. I forgot to click, no? Apply. Okay. Then next for the windward. So, close that. Close this one. Okay, this one. Then we assign. So, shell loads again. Wind pressure coefficient. So, leeward again. So don't use windward in doing in roofs because windward here says only for the windward wall. So as you can see, windward varies. Leeward is constant since it uses QH or the mean roof height H. So this one for WN1, it's negative 0.48. As you can see here, it's negative 0.48. So I'll just put here negative 0.48. So no, just 0.48, not negative, because this is what we call This is positive. The positive here is the suction part. So apply. Okay. Then for WN2, our ano is negative or 34. As you can see, it's 0.034. Okay. So just forward this video if it's too long, no? So I apply it again. Oh, sorry. Just click the previous. I forgot apply. Okay. So let's try to check if let's review our. So this is for WN2. This is the wind, no? Wind normal to the ridge. And this is our windward wall, and that is why zero point 0.8 W, this is windward, negative zero point 0.8. So our side walls, zero point 0.7 L, leeward is constant, which uses QH, 0.5 L, zero point 0.7 L, and 0.568 L. That is all in suction 0.034. So this is WN2. So let's try to see other display. So display our shell for WN1. Apply. So WN1, for WN1, okay. Uh, okay, check, check. So everything is good for WN1. So next we will go to WN2, WP. So WP we don't have yet. So apply. So we don't have yet. We don't have WP2. So just click assign and clear display of assign so that this assigns will go out. So as you can see. Now we go to scenario B. We go to scenario B. Okay. This is scenario B. As you can see here, scenario B is just load pattern 3 and load pattern 4. WP1, WP2, and that is 0.90 and 0.18. So we have mostly the same uh, roof loading. So as you can see here, first let's consider this one and this one. And this is what we call a windward wall. So this is our windward wall. If we consider this as our windward wall assign, then shell loads, wind pressure coefficient. So don't forget to input, no? So don't forget to change, guys, because this will cost you a lot if you forget to change, no? So now we consider WP1. So since this is also a windward, and windward is a positive pressure, so as you can see here, our windward here is zero point 0.8. Our windward is zero point 0.8. So let's try putting windward here. So that is windward negative since it is opposite the direction of the local z-axis. Because the local z-axis, we consider it as a suction or going outside. So negative zero point 0.8. Then click apply. So as you can see here, we have apply. Then also for parallel to. So wind parallel underscore to, let's click PS, no? So that is apply again. Okay. So next, you can also not close that, no? So let's click this one and click this one. So we have selected two shells. As you can see here, we have selected two shells, no? So we have selected two shells. So this means that our side walls, this is our side walls. Uh, this is our side walls, point negative zero point 0.7. So it's the same for both load patterns in scenario B, no? So that is positive. And leeward, don't forget to click leeward. And don't forget to click WP1 or WP2. So WP2, let's say negative zero point 0.7. So apply. You can see here, then WP1 is also, just don't forget to click this get previous selection so you can select it, then apply. And here we can try this back part. So as you can see, this back part, kasi two load shell. So the back part is negative 0.46, or in this case it's positive. So still it is assigned shell loads wind pressure coefficient. Then WP1 is negative 0.46, that is 0.46. Also click leeward, guides, ha? Don't forget leeward, so apply. So leeward apply and WP2 and click leeward. Previous selection I mean. Then apply P2. Leeward, okay, apply P2. So finally, we can go to the roofs, which is the roofs for load pattern 1. The roofs for load pattern 1 is 0.90 and 0.90. For load pattern 2, it's 0.18 and 0.18. That is for the wind direction parallel to the ridge. So we can review that, no? So assign shell loads. So for WP1, that is still use leeward, no? Still use leeward for roof. Don't forget that, guys, ha. Just use leeward for roof. So we have 0.90, so 0.90. So apply, okay. Then for WP2 or the load pattern number 4, wind parallel to the ridge, that is 0.18. So 0.18, we apply, click previous selection, then we click apply. So close. Okay, now let's check. So for WP2, let's check. So our sidewalls is zero point 0.7, zero point 0.7. Our leeward wall is 0.46 leeward. Our windward wall, assuming that our wind is coming from here, no, parallel to the ridge. Our windward wall is negative zero point 0.8. Then our WP2 or the second scenario, second load pattern for wind parallel to ridge is 0.18, 0.18. Next, let's check load assigns for WP1. So WP1, apply. So, okay, let's check. Okay, negative zero point 0.8, zero point 0.7, 0.46, 0.7, 0.9, check, zero point 0.9 check. So, let's try to check again. Other, so let's try to check WN1. So, as you can see here, okay, check, check. So, this is our check. Check. Okay. For WN2, apply, check, check. Okay, now, we now need to put some, what you call that, internal pressure. So how do you put the internal pressure? So this is just easy. Just select all. Okay. So if you want to select all the just click this select, then properties, object type. So let's select walls and floors. It will select all for wind pressure. So we will now for wind internal WI. So the internal pressure, just select all shells. So we have 8 shells, 1, 2, 3, 4, 5, 6, 7, 8. So as you can see here, we'll just input, no, assign shell loads, wind pressure coefficient, then WI. Now, this WI, as you can see in ASC and NSCP, it uses either QZ or QH. But ASC has said that we can use QH conservatively. So, in order that we consider everything as the same, let's try using only QH. So, I will show you the provisions here. It is here in chapter 27. You can see this is the provision here. So, for QI, QH, this can be used for partially enclosed buildings or ano. But QI that is QZ, you can also evaluate it using the height H, or QI is also QH. So this is I'm saying instead of using QZ, we use QH for both. Okay? So as you have understand, let's try. So QH is what? QH is leeward. QH is leeward. Okay. So QH uses leeward. But in this internal pressure, it uses windward down. But anyway, it's for all. So, and roofs for enclosed buildings. Okay. So anyway, let's go and use leeward. So leeward 0.18. Then we try to apply. Okay, close. So as you can see here, this is what we call our internal pressure. This means that our pressure came from inside going outside. So that is the meaning of it, no? So G. So our pressure is from the inside then going outside. So that is our internal pressure. Anyway, it will automatically summed by ETABS, no? So this is how we try to input internal pressure. So as you can see here, meaning this is true in positive 18. So this is 0.18. This means this is positive 0.18. Why? This is not negative 0.18. Why? Because if you are inside, let's try changing blue. If you are inside, it blows positively. As you can see here, it blows positively. So the suction here is this one. So this is a suction, no? So let's try yellow. So this is suction if it's not going towards the shell. This is negative. So if it's going towards the shell like this one, this local z-axis, then it means this is what we call positive. So only the internal pressure is right, no? Unlike the external pressure earlier, we need to flip the sign so that it will account, no? So anyway, I know that you have understand what I'm talking about, no? So here, this is the time we do our load cases. After we define so let's try to check again if our load assigns. So this is just a simple a review. W1, apply. W2, apply. Okay, WP1, apply. Okay, WP2, apply. Okay, and WI, okay. So everything is okay. Now next is our assign, clear display of assign. So next, okay. Our next input is the load and the dead load and the live load. So anyway, dead load and live load are easily assigned, no? So we can assign shell load, so uniform. So we consider this a dead load, no? So what is our dead load and live load? So our dead load is for other, so we have done this. Dead load is 0.14 and 0.3. That is all in all, total is equal to 0.44 kPa. Then 0.96 for live load. So 0.44 kPa, so 0.44 kPa. So direction is gravity. So gravity, just click gravity and don't worry about anything. Okay. Then next, so as you can see, gravity load 0.44. Okay, next. Then next, we apply the uh, live load. So assign shell loads, uniform loads, then live load. So live load is 0.96 and apply it as a gravity load. Then apply, okay. So all in all, our load patterns has been inputted here. Now it's the load cases. No? Later, late in a separate video, we'll try to consider load combination. So this is our load cases here. So we have 4 load cases for normal. So all in all, we have 8 load cases. So what is load case 1? WP underscore 1 plus. So let's try defining it. Define load cases. So let's try to add load cases. Add new case. So WP underscore 1 positive. And let's try add here and add here. So we add the WN1 and the WI. So our WI here is the internal, and it means that since it is positive, so our scale factor is positive. So let's try it's okay. Then we name it WP underscore 1. Then add new case, so add copy of case. So WP 1 negative. And we just change it to negative. Sorry, it's WN1 negative, no? So be careful guys. Use you check, no, WN1, so that is negative. WN1, okay. So I'll try to change this one, modify. So since WP1, we just do it as WN1 because it's WN1, the load name is WN1. Since it is positive, so our internal pressure is 1. Okay. Next, add copy of case. W, add copy of case. So this is W2 minus. So since this is minus and this is normal to the ridge, the second, no, WN2. So, okay. Then add copy of case. We just change it into plus and then we just change this into plus. Okay. Now we go to the positive. So we go to the, so we have accounted here and we have sorry. We have finished this one, we have finished this one. Then we go here now. We do the parallel to the ridge. So another 4. So add new case. So the, we can be sure of loading cases, add. So our WP is WP1 and W internal. So WP1 is 1 and scale factor is, since it's positive, it's also positive. So I'm almost talking for almost 41 minutes now. Then okay. So just review guys before anything because this is important. So add copy of case, WP1 negative. So WP1 negative, you just change this negative 1 again. Okay. Then again, add copy of case, WP2 positive, or let's say negative because we have negative here. Just we want to change here. WP2. Okay. Then finally, the last one of the load cases, of among the 8 load cases, we just change it into plus. So this is 1. Okay. Now we have all in all, we have all our load cases. Now this is the last guys, no? In the next video, I will show you different load combinations for the LRFD and the ASD. So this is, you can try to check. So modify load cases, check. This is check. WN1 positive, check. WN1 negative, check. WN2 minus, check. WN3, so check. WP1, check. Modify show cases, check. Check. Finally, check. Okay, now we have finished all our load cases. Then on the next video, we will try to do load cases. So this is it, guys. Thank you and watch the next video for the finally for the load combinations for LRFD and AS.